Hello everyone, welcome back to your channel. So in today's video, we're going to discuss what is this basically deep learning and artificial neural network. So this deep learning is basically giving human like thinking to computer or system. Okay, let me tell you with an example. Suppose you get hurt in your hand. Now let's say what the hurt is. Suppose you touch the iron or press. Okay, now how it will happen, different neurons in your body will connect and communicate with each other and thereby send final signal to your brain, and your brain will take decision that you need to remove hand from the iron. I guess we all have faced this, right? The moment we touch the iron, heart feeling, right? So this is what is deep learning, right? Basically giving human like thinking to computer or system. Now how we are thinking, that I have mentioned here, right? Neurons in our body interact with each other, communicate with each other, kind of send signal to our brain, and then we are taking a decision. Okay, so this is the deep learning, right? Now ANN stands for artificial neural network. This is basically what? This is a model. What? Architecture that is used to implement human like brain in systems. Okay, right? So this is the complete branch. Deep learning is the complete branch, and this is the one model of that branch. Okay, imagine, you can understand, like you may be getting confused, like what is this deep learning and ANN. Suppose there is a car, so this car is considered as deep learning, and there is another one like Fortuner. So Fortuner is also a car, okay, and it is ANN. Getting kind of this intuition you can take. Okay, these are not deep learning and ANN. I'm giving you an intuition. Getting, like car you can compare it as a deep learning, like a big branch, and one particular type of car, Fortuner, is what ANN. So basically ANN is a kind of deep learning. Okay, deep learning branch. Here what is happening, deep learning is happening. In ANN what is happening, deep learning is happening. Okay, basically in ANN there are three layers. Okay sir, three layers: input layer, hidden layers, and output layer. So input layer we give the raw images or pixels as the input. Okay, let me, what I am trying to understand is that, suppose let's take a problem. Let's take a example problem. Okay, suppose we are building a system that detects what kind of geometric figure is loaded. Okay, that is the whether the figure uploaded is square, triangle, or rectangle. Let's say, let's keep this a small system. Okay, now, so in input we give raw images or pixel as the input. Okay, you can give that images of a square or the pixel values, bytes representing the image. Okay, now this hidden layers will be what doing, processing the images and will kind to try to build or find a pattern. Okay, and finally at the output layer we will be getting the output whether the image uploaded is square or getting some. So this is basically in ANN. Okay, what happens? There is the input layer that you consider as the dibba. Okay, I'm not able to draw diagram here. Dibba. This is the input layer. Okay, there may be multiple dimensions. Input there can be multiple dimensions, right? Suppose there is an image. Okay, and this can be represented by multiple dimensions x, y, z, blah blah blah, right? So there can be first of all at input layer multiple dibba. Consider this as the input layer. Input layer. Consider this as a input layer. Now there can be multiple dibbas inside. Dibba, dibba, dibba. These are hidden layers. Okay, okay. Dibba, dibba, dibba. These are hidden layers. Let me write it down here. Bottom. Hidden layers. And then finally there may be another dibbas that may give the output. What is that? Is the image is square, rectangle, or triangle. Okay. So basically in this input and hidden layers and output there exists a dibba. What is this dibba? Do you know? This dibba is basically a neuron. Dibba is neuron. Now what is this neuron? This neuron can be considered as a switch. Okay, that is 0 or 1 binary. Suppose we give input pixel. Okay, so this neuron will decide, not decide, kind of means can be like whether this input should be passed to next neuron or not. Okay, your input pixel whether this input will be passed to next neuron or not. When it will be passed, when it is 1, then it will be passed to next neuron. If it is 0, not passing. So this is switch. Okay, this is not deciding, this is just a switch. Okay, that will be on and off. When the switch will be on, then the input that is received will be passed to the next neuron. Okay, suppose given pixel whether this input will be passed to the next neuron or not, that is its work. Okay, suppose given input pixel whether this input will be passed to next neuron or not, that is its work. Okay, not deciding. Okay, input is coming, that decision will be taken by someone else whether to make the on the switch or off the switch. Okay, if the switch is on, this neuron is basically a switch. Try to understand. If you're getting confused, try to understand. I will make it clear. Okay, so this is a switch, just a switch. If one, that is if it is on, then pass the data to next neuron. Okay, switch if 0, then don't pass the data to next neuron. Simple as that. This is there. Okay, let me highlight it. Okay, 0. Okay, so this is there. Consider as an example, suppose our human brain. Okay, our friend calls to us. Our brain is there. Okay, our brain is there, and our friend calls to us. We may have multiple friends, right? Okay. Now consider this friend call as the input and uh, our brain as the neuron. That is, either if it is 1, then pick the friend's call. If it is 0, don't pick the friend's call. Okay. Now see how I will relate to this everyone. See, every phone call, every phone call or input has a weight associated with it. We all have some priority list, right? Suppose a random person calls you at night, 2 o'clock. Will you be picking the call? You won't be picking, right? Because that has no weightage. Getting? So every phone call or input has a weight associated with it. The more the weight is, the better chances the data will play the input. The input will play a better part the in the output. Output is what? Picking the call. Okay. So the more the weight is, the better the chances the input will play a better part in the output. That is okay. So if I have a very high priority friend who has a very high weightage in life, I'll be picking the call. Right? Getting same thing. So every input has a weight associated with it. See, now you would be thinking, is this input only one layer or this hidden layer is only one dibba? Actually, sir, this input layer is only one. Okay. But this hidden layer is multiple. Okay. And each layer output kind of acts as a input for the next hidden layer. So that is what I am telling. Okay. So every input that is coming to the hidden layer, okay, there will be multiple hidden layers, has a weight associated with it. If it is a higher weight, there are very high chances that input will be passed to the next hidden layer, or it will be doing a very high contribution. So I give you example of a real life. Suppose you get a call at night. You have a multiple friends. So you will be picking the call or not depends upon what weightage that person has in your life. Okay. So the more the weight is, the better the chances that you will be picking the call. Okay. Weight understood, right? Every phone call or input has a weight associated with it. Okay. The more the weight is, the better chances the input will play better. So weight becomes very important. Weight becomes very important. Okay. Suppose you give a higher weightage to a wrong input or wrong friend, the result may not be good, right? So with time, by failing or rejections, we learn where we should give weightage, right? Like which input requires input or person requires more weightage in our life. Getting? So if you give, so if you give give correct weightage to the correct input or person in life, your life will be successful, happy, and output will be 100% correct. That's will be correct. 100% is nothing. Getting? So I have kind of understood, right? Given you example, I have a real life also, right? Like how this work. Every input has a weight associated with it, just like all the people around us has a weight associated with it. Okay. So the more the weight is, the more influence of that person in our life, more the influence of that input in that output. Getting? Kind of give you example. You can again go through this. Okay. Like let me highlight the points. Like this is important. All these points are important, sir. All these points are. Now coming to bias. Sir, bias is very important. A sensitive person starts giving weightage to all people in life. Doing this, he gets emotional breakdown and getting lost at the end. Not giving correct output or not able to reach the level that he deserves. So we must set a biases. Must set a biases. Okay, that the person has invested or made this much of efforts in our life, then kind of will give a required result, that is pass, keep that data or friendship till future. So this I told you a story, right? So we should not be too much sensitive, right? We should must keep a biases that if this much we are getting something in somewhere in relationship or friend, we should continue the same thing. Okay. So this neuron, all these neurons has a biases set with it. Okay. Which is added with the weights. Okay. So that weights to make neuron at what level it will pass the data to neuron. Let me explain you with example. Suppose it happens like this. Suppose y equal to mx plus c equation. Okay, y equal to mx1 plus c. This c is there, no? This is the biases. Now neuron has a limit set. Suppose neuron has a limit set. When value, just example, not really, just example, is 100, then pass the data to next neuron. Okay, so suppose y is m is suppose the constant whatever like be 2, x is 80. Okay, so if the biases here is 1, okay, so it won't pass. It won't pass. So if the biases here we increase 2 into 80 plus let's say good biases like 20, it will 100. Yes, it will pass. Now if you make the biases very high, then anyone with a very low energy will come. Suppose let's take biases as 90. Okay, so anyone with even a 10 energy will come and 90 will be your biases and 100, and you will pass the next. Okay, so here if you see a person who is having a very less weightage because of your very high biases, you are going this forward, getting. So biases is kind of controlling. Let's write the final thing. Biases is kind of controlling how sensitive the neuron is. But so till now we have three things. Neuron is what a switch. Based on the switch is on or off, it is passing the data to the next level. How it is passing the data? Based on weightage. The higher the weightage, the higher the chances that input will be passed to the next stage. Now there must be a bias associated with the neuron. Okay, like whether when this much investment or when this much happens, then only will passing to the next stage. Like you saw, right? This is what bias is. Let me write it down. You don't get confused. The bias, the bias. Okay, 2 into 80, like say something like that. It was suppose 80. Okay, 80. And let's say m value was 2. Okay, so here the x is equal to 40, equal to 40. Here is also x is equal to 40, and here x is equal to 5. Got it? So this is what it is there. Okay, you can also make it highlighted. Now let's move to activation function. The activation function is the main guard, sir. Main guard or brain that decides whether the data should be passed to the next neuron. Not. So there are different activation functions like Sigmoid, Tanh, ReLU. Okay, kind of 0 or 1. Okay, like if data is negative, negative, then 0. Data is positive, then 1. This is for the sigmoid function. Now let me correct this. I have made a mistake of the sigmoid. I am getting confused. So see, straightforward in you. I will type here what are the different activation functions. Let's get it correct here only when ChatGPT is here with us. See here sigmoid. Simply 0 or 1, right? Simply 0 or 1. So this you can go through. You can just type here. If you want to go in more detail, you can just come up to the chat gpt, like whatever I am content I am doing, you can understand it, and again like kind of do chat gpt or do some kind of research or something if you want to go in detail. There is always a path to again go forward or grow, right? So this is this activation function. Now what is forward propagation? Now let me explain with an example. That same one, right? Same one. Let's bring this again here. Okay, so you uploaded an image, or you gave. See, when we come first time in life, when we come first, generally we give random weights to everyone in life. Yeah, input. Okay, because we don't know what is the correct weight for that person or input. I'm relating with person, just relate with life, sir. This is totally deep learning is related with life. Okay, so We start randomly investing on every person. Okay, after some time we face something, energy down, something, then we kind of back propagate and change the weights. Okay, to this person I am not to give this much weightage in life. Same happens with input. So, telling, suppose you give the input, right? Square image you uploaded. Okay, square images you uploaded, or something you trained it. Okay, and you give a random image. You gave a random image to model. Give random weights and ask like, what image is this? What image is this? Suppose the equation was y equals to 8 is considered as a weight. Okay, into 1 into 4. For triangle the weight was suppose 6 into 2, and for, let me, rectangle the weight was something 5.2. Okay, now the probability was calculated. Let's make it within 1. Let's make 1 so that it becomes related with that activation function, right? Let's make it as 0.2 was the weight associated with this one. 0.8 was the weight associated with the triangle. See, I have not prepared something. I am randomly, just whatever I have understood, I am trying to explain, not editing any video. Okay. Thinking, assuming everything, telling from my heart. Square, okay, has 0.2 weight. Okay. Triangle has 0.6 weight. Rectangle has 0.1 weight. 3. So we did some calculation. So we did some calculation, that is y is equal to mx plus c. Let's say c is 0. Okay, so from the final output layer, square, for square it came as, okay, y is equal to 0.2x. Triangle came as y is equal to 0.6x. Getting? And for rectangle came as y is equal to 0.3x. Okay, so let's suppose now to the output layer it will come. Output layer it will come. This three, this three. Okay, that for the image is a square, its probability is 0.2x. The image, it is a triangle, its probability is 0.6x. And it is a rectangle, its probability is 0.3x. What is the final output? Triangle, right? But let's say the actual image was square. Getting? Let me again explain you till here. So whatever objective is, you have built a system that detects what kind of geometry figure it is, square, triangle or rectangle. So first of all, we give random weights to every input. Okay, because we don't know what is the correct weight for each input or each category. So suppose there is a square. Okay, the chance that the image is square, we give weight is as 0.2. Actually what happens, no, let me tell you what happens. We kind of represent everything with the equation. Okay, this equation is, you would be getting confused like, what is this square, triangle, how it is given as input. I know it, you will understand. See, y is equal to mx2 plus mx3. Do you know what is this x1, x2 and x3? These are the parameters. So, or kind of different variables. Now what variables are there in our system? Square, triangle and rectangle. Okay, so this is there, right? And what is m? Like, is the m1, m2, m3. this M1, this M1, M2, and M3 are the weights. Now I guess I am clear. Okay, so these are the weights. So this is M1, this is M2, this is M3. So this is basically how the input comes. Okay, so there will be different dibbas. Will be different dibbas, different dibbas, different dibbas. Okay, so here we will be putting value for square, pixel value for square there. Similarly, we will be writing the equation, right, corresponding to this. Okay, and the same way the input will become. Okay, and based on which has higher weightage, like if you see here, this triangle had higher weightage. So our model kind of output layer predicted as it is a triangle. Let's say the actual image was square. So what happened? We gave wrong weightage. Actually, the probability that the image is square was to be high, but it's low. But it's actually low. It means what? Weightage of square needs to be increased. Okay, right? And the probability of image being a triangle is low. The probability of image being a triangle is low in reality, but output going high, to be high, but output, but its output low, going high. Okay, output showing high. So what needs to be done? Its weights to be reduced. That is weightage of triangle. See? So this is what basically happens. Okay, in backpropagation. What happens in backpropagation? Write it down. Got it? This is how every image comes. Okay, going like how much is the weightage of this having a square, having a rectangle, triangle, getting this M1, M2, M3 are the weights, and this x1, x2, x3. These are the parameters or different kind of variables, square, triangle, rectangle, getting. For square, the weightage we had given was 0.2. For triangle, the weightage we had given was 0.6. For rectangle, we had given the weightage as 0.3 at the beginning. Okay. So we did some calculation, that is y is equal to mx plus c. Okay. And we found out that for y, it was coming square as 0.2x contribution, triangle 0.6x contribution, and rectangle 0.6x contribution. So y altogether square corresponding, let's make clear so that no confusion happens. So y becomes 0.2x, 2x, 0.6x plus 0.3x. Got it? And the output layer 0.3 rectangle 0.336. Okay. So based on who had higher weightage had with triangle. So output layer kind of predicted triangle, but in reality actual image was square. So we did some back propagation. So this is what is there. Okay, got it? So initially we start with random weights. We see this is how the variable is represented. Y equal to ms1, x2, ms2, x3. This x1, x1, 3 are the different variables. For our system, the different variables are square, triangle, and rectangle. From the image, we need to distinguish whether square, triangle, or rectangle. For each of this square, triangle, or rectangle, there is a weight associated. Okay, higher the weight, higher the chances that will become the output. So as we had given triangle as the more weightage, so in the output, triangle came as the final output, kind of predicted triangle. But that was wrong. Why? Because we had given more weightage to that triangle. Okay, so we needed to kind of do reduce the weightage that we are giving to the triangle. Accordingly, just fine tuning it, updating the model. This is only what is fine tuning. Okay, updating the weights. When we say training the model, training the model, we are kind of updating the weights step by step till we reach to the desired level of accuracy. Some important points. Every neuron has a weight and devices associated with it. Devices and activation function it. There are multiple neurons present in NN that are connected through a network. Now, if you are getting a confusion like how this NN look, just come to ChatGPT now. Just come to ChatGPT. Please go me create architecture of portable hidden layers for NN. See, it will create. Oh my god, did you want to creating an image? I expected that it will just be giving that. Let's see what it is. Till now, search here. See, got it. Don't need to go there. See, in this is the input layer. Okay, and there are multiple hidden layers. Okay, and there is the output. So here you give weightage like x1, x2, x3. Okay, what is the value for square? What is the value for being a triangle? What is the value for being a rectangle? Then it goes to hidden layer. There happens some calculation. Here also happens some calculation, and at the end we are getting the output. Okay. This is a very deep thing, sir. I have tried to give you a spot understanding, like basic understanding, because yeah, we are learning generative AI, but we should have clarity of these concepts. Okay, this is again a very big, deep field. Okay, as I told, we want to be focused on generative AI. We want to learn generative AI in less time, less efforts. So that's there. Okay, if you have time, you can go through it. No problem. Okay, that's all. Let's see if it's connected, created or not. So same thing, better only. This one only. Okay. So see, every time ChatGPT is not going to give the result kind of result that we want. Okay. But see, it has given, sir. It's not like that. See, everything is written input function, activation function, right? Just take take this screenshot, or just you can by yourself type it down in ChatGPT also, right? So that's all for today. In the next lecture, we'll be starting with generative AI, its working, how it works. Okay, so that's all for today. Again, Sam, signing off.